Good morning, this is your Stats Sensei, Mr. Spensei, and this is test review, and this will be one sample proportion hypothesis test. And the scenario is going to be, where's my package? Emma works for a logistics company that handles thousands of packages every day. Okay, change pen color. But that thousands to me give us some idea of the population. So that's probably the population size right there. Probably ought to highlight that. The company has always prided itself on timely deliveries, but recently Emma has noticed an increase in customer complaints about delayed shipments. According to studies, approximately 10% of packages delivered by courier companies are delayed. All right, so it looks like to me, it looks like we have a null hypothesis or we have a claim of 10%. However, Emma suspected the delay rate at her company may be higher. Tells me that I'm probably going to be looking for an HA of greater than. She decides to investigate by random sampling 103 packages of the more than 10,000 that were delivered. All right, so we have a sample size of 103. We now know that the population is not thousands, the population is 10,000, and that's going to be important later for our conditions. So the population is 10,000. Of these 103 packages, 15 were delivered late. So X equals 15. Emma is now concerned that the delay rate at her company may be above the industry standard, and she wants to test her suspicions. Test the company's claim that more than 10% of the packages are delivered late at a significance level. Okay, so we're looking for a greater than 10% as our alternative. That's what we suspected at an alpha level of 0.05. So in this case, our significance level is 0.05. All right, so we know we're doing a hypothesis test, and it's just simply sample proportion minus population proportion. Remember, when you're working with the standard error or the standard deviation for a sample proportion, it's always going to be the population for the test. So in other words, it'll always be P for the test. If it's a confidence interval, it's P hat. All right, well, our information, we've already collected it. We said, hey, you know what? 15 packages out of the sample size of 103, which is right here. And they told us the population claim up here was 10% of the packages are delivered late or delayed. They did not give us P hat, so we had to calculate that. And we merely went P hat equals X over N. So 15 divided by the 103. And when we did that, we get 0.1456. That's where that came from. The inference procedure, one proportion z-test. All right. And that's not a surprise there at all. All right. So when we go about drawing this thing, remember it's a hypothesis test. So you're going to have to be centered on P. So sure enough, here we are. We're centered on our 10%. We're centered on the population. There's our P hat of 1456, which was basically that X over N that we calculated previously. And notice that we have a greater than here, but that's also what we indicated when we were reading this. We thought, oh, alternative greater than, because we said more. All of this needs to jive together. It all needs to complement each other. When we plug in, we simply are plugging in our P. This is our P hat, so 1456. Our claim, well, the population claim was 10%, so that goes there. And then also the 10% is dropping in here and here, and there's our sample size right here. So please remember, this is the P, this is P hat, and this is N. Okay? All right, it's the null hypothesis. Well, the null hypothesis is that it equals P. In other words, that it equals 10%. So the claim is 10%. The alternative is that it's greater than 10%. And once again, as I said before, we're going to be consistent. We have a greater than here, we have a greater than here, and we indicated more than 10%. If you'd preferred, you could have written HO P naught equals 10%, HA P naught is, greater than 10%. All right, it's up to you. Just always remember when it's a percent, always take your percent and divide it by 100. So 10 divided by 100 equals 0.1, and that's where that came from. Our parameter, let P, the true population proportion of courier packages delivered late. All right, and this is delivered late by Emma's company. All right, and we want to make sure that we have proportion, and this is our context. Then we need to look at our conditions. Well, our first condition is random sample. So let's look back at our scenario. All right. So when we look back at our scenario, she randomly sampled 103 packages of the more than 10,000. Great. So the first condition is random sample. And so we have random sample of 103. And that was given to us. Yay. So we can check that off. The next thing, we need to make sure that our sample is not too big. So we go, okay, the sample size is 103. 103 times 10 is 1,030. But they told us that they had 10,000 packages. So that's good because we can say N is less than 10% of the population. And we go ahead and check that off. Met that condition. Now that we made sure our sample wasn't too big, we have to make sure it was big enough. And so we're going to go NP. Now, please remember, super, super important. When we're working with tests, we're working with the population proportion. So we have to have P. Confidence intervals, this will be P hat. But for the test, it's going to be P. So 103 times 0.1. Well, what is 103 times 0.1? Well, that's 10.3. That's greater than 10. Not by much, but it's still bigger. And then we have 103. And by the way, I'll just go ahead and do both of these. 103 times 0.1. All right, 10.3. Then I do 103 parenthesis, 1 minus 0.1 close parenthesis, and I get 92.7. And that's also greater than 10. So in this case, both things have to be true, and they are. So we can say the sample is large enough. And if you're an AP Stats, you would write the sample is large enough to use the normal approximation. But all we need is the sample is large enough here. Okay, so we've done all that work. Let's go ahead and run this test. We've already done all the hard part. Let's run it and find out what happens. So stat test, drop down to number 5, one proportion z-test. All right, the claim was 10%. The x was 15. The n is 103. And we said greater than, so we need to be consistent. And I get 0.06. Now remember, we're comparing it to an alpha of 0.05. So 1.5436 equals 0.063. That's my p-value. 0.00613 is greater than 0.05. Because it's greater, we're going to fail to reject. All right, so now that we've run that, let's go ahead and do our conclusion. And by the way, once again, that just came off the calculator. There's the 1.543, there's the 0.0613, and then we're comparing it to the alpha that they gave us up at the top. All right, the alpha 0.05. So, our p-value is 0.0613, which is greater than our alpha of 0.05. We fail to reject a null. All right, I can't stress this enough, so I keep going back to it. This information right here, you've already shown. It came straight from that box. Our p-value of 0.0613, which is greater than our alpha 0.05. Our decision was to fail to reject. Okay, and that's exactly what we said there. So there is not, make sure that that's a not, don't mess that up. There is not sufficient evidence to suggest that the true population proportion of courier package delivered late is more than 10%. Once again, this right here, that's a restatement of the parameter. Always take time to write a good parameter because that's we're going to show up again. And then it says is more than 10%. Well, that's the alternative hypothesis. We wrote it in words because our alternative hypothesis was P is greater than 10%. The proportion is greater than 10%. Greater than is another way of saying more than 10%. So that's the hypothesis test for where's my package. I hope it helped. Look forward to seeing you on the next one. Thanks for watching.